These are the notes for section 3.2, part 2. We're going to be solving systems of equations again, but this time we're going to be solving them by something called elimination. And I actually really like that this is called solving by elimination because it really describes exactly what you do in these problems. So when you're solving by elimination, now this is opposed to graphing and seeing where they cross, or substitution, where we plugged one variable's value into a different equation. When we're solving by elimination, we have to have a couple things true. So one thing that has to be true is that both of your equations must be in standard form. Now, there is a way to do this if they're not in standard form, but for our purposes, to make this as easy as we can, we want both of our equations to be in standard form. Remember, that's where your x and your y variables or terms are on the same side. And what's going to happen is one variable eliminates, I'm putting that in quotes because it's not really a very math word, when you're adding the equations. So one variable, meaning your x or your y, if those are the two variables we're working with, gets crossed out of the equation when we add up the two equations. And this will make more sense once we do an example. So pause if you need more time, but I'm going to do an example here on the next page. All right, so like we've talked about, we're going to solve this system, and we're going to use that symbol if you can to show, hey, these two equations are in a system. So 2x minus 3y equals 0, and negative 4x plus 3y equals negative 1. So we're going to solve this system using elimination. We're starting off with the easiest one we can, because what we're going to do is we're going to add up these two equations here. So you always want to put them in standard form so that your x's are stacked over each other, your y's are stacked over each other, and then you have constants on the other side. And if we look at this right now, our y values are going to eliminate, because if we add negative 3y plus 3y, well, that's 0y, so that's just 0. We don't even have to write it. So those eliminate, and that's always our goal when we're solving by elimination. We want one of the variables, either x or y, doesn't matter which one, but not both. You want one of them to eliminate. So you want them basically to be the same number coefficient, but opposites. So negative 3 and positive 3 were our y coefficients here, which made it eliminate. Now we're just going to add up the rest of our equation. So for my x's, I have 2x minus 4x, that's negative 2x, equals 0 plus negative 1, that's negative 1. Now this is just like a regular equation, just solve it like this. So I'm trying to get x by itself here, so I'm going to divide each side by negative 2. So I'm left with x equals, well, negative over negative is a positive, so x equals 1/2. I like to box that in so I kind of have it nice and neat on my paper, and I can refer back to that easily. So once you have one of your variables, all you have to do is plug it into either equation, and you can find the value of your other variable. So I'm going to decide I think I'm going to plug this x in right there in my first equation. So I'll do that right over here. So I've got 2x minus 3y equals 0. And I'm going to plug in 1/2 for x because I know that x is 1/2. So I'm going to do 2 times 1/2 minus 3y equals 0. So now let's just solve this for y. 2 times 1/2, that means 1/2 of 2. So that's 1 minus 3y equals 0. Now I just need to get this y by itself, so I have to undo adding and subtracting first. So I'm going to subtract 1 from each side here. I'm left with negative 3y equals negative 1. and then just divide by -3. So we're left with y equals -1 over -3, which simplifies to +1/3. So there's the value of my other variable. So your last step, as usual, is we just need to write these as 1 point. So 1/2, 1/3. If we went to that point, if we had graphed those lines, that's where those lines would meet. So I'm going to give you guys a similar one, same difficulty level, that I want you guys to try on your own. So pause this if you need more time to write this down. But here on the next page is one for you guys to try. So here's my system. -2x minus 7y equals 3, and 6x plus 7y equals -2. So I want you to solve that by elimination. We'll go over it in class tomorrow. All right, so we're going to do another example here that gets a little more difficult. So here's my system. 5x plus 4y equals 22, and -3x plus 8y equals 18. If we look at that system right now, if I added those up right now, my x's would not eliminate because 5x plus -3x is 2x, and 4y plus 8y is 12y, so neither would eliminate. So sometimes you have to change one or maybe even both of your equations to make something eliminate. So you want to look at your coefficients of x and look at your coefficients of your y's and see if there's something nice and easy you could do to make them eliminate, to make just one of your variables eliminate. So maybe take a second and look at this one and see if you can think of something you could multiply one of those equations by, and it would make one of those variables eliminate. So what I'm thinking here is if this 4, if I multiplied that by a -2, that would be -8, and that would eliminate with the +8 below it. That would be great. So what I'm going to do is I'm going to multiply this whole equation times -2. So you can't just multiply one term, unfortunately. You have to multiply the whole equation. So I'm going to rewrite that equation over here, and I'm going to multiply it all by -2. So 5x times -2 is -10x minus 8y, because I multiplied it by -2, equals -44, because I multiplied that 22 by -2. The bottom equation, I'm just going to keep it the same because that way those y's will eliminate. So now I'm going to add these up. We really didn't change anything. We just changed the way the top equation looks. So -8y plus 8y, that eliminates. That is great. So we are left with -10x plus -3x. That's -13x. Equals -44 plus 18, and that is -26. Now, look how great this is. All we have to do is to get this x by itself, we just divide by -13 on each side. So we're left with x equals negative over negative is positive, and 26 divided by 13 is 2. So we're already halfway there. We've got half of our answer. A lot of people end up liking this method of elimination better than substitution. It does work nicely when it's like this and it kind of everything comes together and the numbers all work really nicely. So remember now we just have to plug that 2 into either equation. It doesn't really matter which one. I'm going to plug it in this top one just because I did the top one last time, but you could do either one. So I'm going to do 5x, so 5 times 2 plus 4y equals 22. That's coming from right there. The top equation, I just plugged in 2 for x because I know that x is 2. Now we just need to get y by itself here. So 5 times 2 is 10 plus 4y equals 22. Then I can subtract 10 from each side. So I'm left with 4y equals 12. And you just divide by 4 on each side, and we are left with y equals 3. And again, I just like to box those values in as I go, just so when I'm looking back at my work to try and find that coordinate point where they cross, which in this case is 2, 3. That's x, y, 2, 3. It's just easy to find it in my work. So I'm going to give you guys one where you're going to have to do something similar. You're going to have to change one of these equations to make something eliminate. All right, I want you guys to try solving this system. 2x minus 3y equals 8, and 6x plus 5y equals 4. So I want you to solve that system by elimination, and you are going to have to change one of those equations. You're going to have to multiply it by something to make one of those variables eliminate. So try that one, and we'll go over it in class tomorrow. I've got one more example after this one. All right, so we're going to do one more example together here. This is the last example we're doing. So it's 2x plus 3y equals 17, and 5x plus 7y equals 29. So if we look at this equation as it is right now, or this system, the x's don't eliminate, the y's don't eliminate. And the problem is there's nothing you can multiply this 2 by to get negative 5, so that eliminates, and there's nothing you can multiply that 3 by to get negative 7. Well, I guess you could do a decimal, but I don't really want to deal with decimals. So what we can do if, oh, didn't know that eraser was going to be so big. What we can do in a situation like this, where we probably just want to work with whole numbers here, no fractions or decimals, what we can do is we can multiply both equations by something. So it's up to you. You can just choose to eliminate the x's or the y's. What I'm thinking right now is maybe I'll do the x's just because, I don't know, I like the numbers 2 and 5 better than I like 3 and 7. Although 3 is my favorite number. But I'm gonna try and eliminate the x's. So I'm thinking that the least common multiple that 2 and 5 have is 10. So I'm gonna make this top equation, I'm gonna multiply it by 5 so that I've got 10x plus 15y equals 17 times 5, so that is 85. Actually, you know what? I changed my mind because I'm going to do it the same as I have it on my notes because I know the answer is that way. I'm going to multiply it by negative 5, so that's going to make it a negative 10x minus 15y equals negative 85. So I multiplied that one by negative 5 so that my x coefficient is negative 10. That means I want to multiply this equation by something so that my x coefficient is positive 10, so that those will eliminate. So I need to multiply that one by positive 2, because then, let's multiply that out. 5x times 2 is 10x. 7y times 2 is 14y, and 29 times 2 is 58. So now if I add those equations up, I made my x's so that they eliminate. I've got a positive 10 and a negative 10. Well, negative 10 plus positive 10 is 0. 0x is just 0, so those eliminated. And now let's add the rest of it up. So negative 15y plus 14y is negative 1y. And negative 85 plus 58 is negative 17. Then we just need to divide that by negative 1. So we know that y equals positive 17. And I'm just not realizing that I didn't finish this on my paper, so this is going to be a good test of my math skills here. All right, so let's go ahead and we just need to plug that into one of our equations, and we'll be able to figure out what x is. So we've got 2x. I'm going to plug it in the top one. I just like plugging in the top one. And I'm thinking, okay, I have to do y times this number, so I'd rather do 17 times 3 instead of 17 times 7. So I've got 2x plus 3 times 17, that's my new y value, equals 17. That just comes from this equation, that top equation. I just plugged in my y. So now let's get x by itself. So I've got 2x plus, let's see, 3 times 17. 51. All right, so now to get this x by itself, I just need to undo my addition and subtraction first. So I'm going to subtract 51 from each side. So let's see what I've got left here. I've got 2x equals 17 minus 51. I think that's negative 34. And then all I've got to do is divide by 2. I hope that's right. So x equals negative 17. Huh. All right, that was nice. So my x value is negative 17. That comes first in my coordinate. And my y value is positive 17. So I believe that's correct. I didn't have that worked out beforehand, though, so you guys let me know if I got that wrong. All right, so that's our last one. Come in tomorrow ready to practice some problems like this.